Hello everyone. Now let me explain how to use the Python program to compute the hash value for a given password using salt. Then to again hash value is computed for the same password, and both the hash values previously computed and the hash value computed next, both are compared to check whether the password is matching. In any system servers, the passwords are not stored as plain text. Why? If some person without any authorization is able to access a system, then there is a possibility for the person to access the passwords. If the password is accessed by unauthorized person, that person can misuse the passwords. So in order to protect from these kind of unwanted situations, passwords are basically stored as plain text, as hash values in the systems, servers and database systems. Now let me explain this Python program, which would compute the hash values for a given password. So let us begin here. P is equal to getPass dot getPass. So what is this code statement is doing is, getPass is a method and this method is in this object getPass. So this method would prompt the user to enter the password in the terminal. Now if I run, it is asking the password. So here I am entering the password. So when the password is entered, so it is it goes as an input into the process. Is it clear to you? Let me see what's the problem. Okay. So this method is used to get the input. Now the input is stored in the variable p. So the input value, so here the input value is this password. This is the password. So the input value is stored in the variable p and it is encoded, and encoded password is stored in another variable input string, that is input str. So just we are encoding the value. Suppose you want to know how the encoded password would look like, and you can see here print encoded password. Then put input str. So run this and now you can check. You can see the encoded password. It looks like this. The letter B is attached here. So this is the encoded password. Now just a minute. Then hash value is calculated. So hash lib is a object. In that you have SHA-256 For this method you pass an input string, encoded password as the input, and call the hex digest method. So what it would do, it would compute the hash value. The hash value would size would be 256 bits, and it would be represented in the hexadecimal format. You can see this hexadecimal format. If you convert this into binary value, it would be of 256 bits size. Now we are printing the password. Clear? Now here so what we are doing again here is, I will come back to this, okay, just little later. So here it's a very simple code. We get the password from the user, encode the password and then compute the hash value and print the hash value. Then again what we do is, we second time also, here you can see we get the same password. Let me run again. So we again the user is prompted to enter the password. Okay, again the password is encoded, then encoded password is hashed into hexadecimal format. Okay, so this one is okay, let's say this is the second hash value, this is the first hash value. Now here what we do, we compare the first hash value with the second hash value. So if they are matching, okay, we print the password is matching. If the not matching, then the password do not match. You know that when the user enter the password would be stored in system as a hash value. So for the second time, when the user is entering the system, when during the authentication process, the user has to enter the password again, correct? So when the user is entering the password again next time, the system, the process has to compute the hash value. So the previously computed hash value which is stored in the system and the hash value which is computed now during the login process should be matching. If they are not matching, then the authentication process would fail. Clear? So most of the time, okay, so the password, the same plain text would produce the same hash values. However, this has a slight weakness. What weakness? There are hash dictionaries available. So using the hash dictionary, the attacker can using the brute force attack can find out the correct plain text for a given hash value password as a hash value. So you from the dictionary, you can try all the possible hash values in the dictionary. So when any hash value matches, then you can find the corresponding password plain text. So in order to make things complex, in order to mitigate this kind of attack, okay, we along with the password, okay, we will add a string of pattern of string characters. Okay, so that is called salt. Okay, so this method here is used to generate 16 characters of salt value. Here the input is this. For example, for this method we are giving from A to Z, and from number 0 to 9 we are giving. from that we are asking this method, okay, please select some salt value of 16 letters. Suppose you want more size, then you can increase the size here also, like 17 or 18. It is up to the user requirement. So what this method would do, it would choose 16 letters from this string of characters, array of characters. It would choose 16 randomly in any order. Okay, you cannot predict. So and it would give that salt value okay, to the user, to the system, and the the process can mix this salt value with the password like this. So not only password is encoded and hashed, but along with the password, this random values also mixed. So here also, while both the times we are computing the hash values, so for both calculation we use the same salt value. Okay, now okay, you can see it would produce a different hash value. I am entering the same password and the passwords are matching, and also the hash value is little complex in nature for the attackers to crack the plain text, that is password. To get the password from this hash value, it is very difficult. Why? Because we are mixing the salt with the password before for calculating the hash values. So this salt value, the attacker, if the attacker wants to crack the password, then he should be knowing this salt value. Okay, so now the complexity has increased. Amount of effort the attacker has to put in to crack the password increases. So he has to figure out what is the exact salt value, okay, in order to crack the password. So by this way, the salt values increases the security of the password stored in the system. So this is what I want to convey in this today's lab session. Okay, so you can go to programmiss.com, okay, Python programming. You can Google and find any online Python IDE compiler, online compiler, and you can enter this program and you can run and verify. Okay, thank you very much.